I'm Eva Ortega and I'm going to work a problem consisting of transition matrices and coordinates. This problem is from chapter 3, section 5, exercise 5. The problem states, let U1 equal 1, 1, 1 transpose, U2 equals to 1, 2, 2 transpose, and U3 equals to 2, 3, 4 transpose. Part A is find the transition matrix corresponding to the change of bases from E1, E2, E3 to U1, U2, U3. Part B is find the coordinates of each of the following vectors with respect to U1, U2, U3, and the following vectors are given. Before we start working out the problem, let's review some information about transition matrices and coordinates. For transition matrices, if we are changing from the matrix U to the standard matrix E, then the transition matrix would just be U. If we are changing from the standard matrix E to the matrix U, then the transition matrix will be U inverse. For our problem, we are going to be using this one. Now, coordinates with respect to U. We use the equation x equals U times d, where x is the vector given and d is the coordinate. Since we want to find the coordinates, we want to have d alone. So to do that, we multiply U inverse to both sides. We know that U inverse times U equals the identity matrix, so then we have U inverse times x equals to d. We are going to use this equation for our problem. Now back to our problem. We have that U1 equals to 1, 1, 1 transpose, U2 equals to 1, 2, 2 transpose, and U3 equals to 2, 3, 4 transpose. Using these vectors, we can make the matrix U equals to 1, 1, 2, 1, 2, 3, and 1, 2, 4. So our part A states, find the transition matrix corresponding to the change of bases from E1, E2, E3 to U1, U2, U3. Remember, we're going to use this part of our definition. So now we just find U inverse. To find our U inverse, we can use the equation U inverse equals to 1 over the determinant times the adjoint of U. So let's first find our determinant of U. So we have the determinant of 1, 1, 1, 1, 2, 3, 1, 2, 4. I'm going to use the first row. So we have 1 times 8 minus 6 minus 1 times 4 minus 3 plus 2 times 2 minus 2, which is 2 minus 1, which is 1. So our determinant of U equals 1. Now we find the adjoint of U. To find the adjoint of U, we replace each term by its cofactor. Then transpose it till we have 2, negative 1, 0, 0, 2, negative 1, and negative 1, negative 1, 1. Then we transpose that and we get 2, 0, negative 1, negative 1, 2, 0, negative 1, 2, negative 1, 0, negative 1, 1. That is our adjoint of U. Now we go back to our equation and substitute our determinant and our adjoint of U. Our final result is just that we get our adjoint matrix, so we get U inverse equals to 2, 0, negative 1, negative 1, 2, negative 1, and 0, negative 1, 1, which is a transition matrix corresponding to the change of bases from E1, E2, E3 to U1, U2, U3. Now, our part B says, find the coordinates of each of the following vectors. We're going to do these one by one. Now remember that for this part of our problem, we're going to be using this equation, U inverse times x equals to d. Our first vector given is 3, 2, 5 transpose. We're going to name this vector x, and we know our U inverse from part A. Now we just substitute what we have into our equation. So we have our U inverse times our x. Now doing regular matrix multiplication, we get 6 plus 0 minus 5, negative 3 plus 4 minus 5, and 0, negative 2 plus 5, which reduces down to 1, negative 4, 3, which is our d. These are the coordinates of x with respect to U1, U2, U3. Now for our second vector, we repeat the same thing. Our vector is 1, 1, 2 transpose. We name it x, and we have our U inverse. We do the same thing of substituting them into our equation. We multiply our matrix and get our coordinates 0, negative 1, 1. These are the coordinates of our x with respect to U1, U2, U3. Now the same thing for our third vector. 2, 3, 2 transpose. We repeat the same procedure and we get that the coordinates are 2, 2, and 1 for this particular vector with respect to u1, u2, u3. I hope this helps you guys. Thank you.